Right now, deep beneath the Earth's crust, human beings are detonating thousands of pounds of high explosives to shatter solid rock, all to hunt for a microscopic prize. Welcome to the extreme world of industrial gold mining. To pull just one single ounce of pure gold from the earth, engineers have to blast, haul, and chemically crush over 30 tons of raw mountain. We are stepping inside a multi-billion-dollar operation to witness the entire violent, high-stakes journey, from subterranean explosions that rattle your bones to toxic chemical leaching tanks, all the way to the blinding 2,000-degree furnace where pure, molten gold is finally poured into massive bullion bars. The scale of this operation is staggering, the dangers are real, and the transformation is unbelievable. Let's head underground. Right now, 3,300 metric tons of gold are pulled out of the earth every single year. The global gold mining market was valued at over $260 billion in 2024 and is projected to explode toward $710 billion by 2033. Gold production in 2024 hit a new all-time record, surpassing every previous year in modern history. That gold is coming from somewhere. Let's go find it. It starts long before any blast goes off. Finding gold is a science that takes years and costs hundreds of millions of dollars. Geologists use satellite imaging, seismic surveys, and geochemical analysis to locate ore deposits buried hundreds, sometimes thousands of meters underground. When a target zone is identified, drill rigs sink core holes along cylindrical rock samples extracted from deep below the surface. These cores are analyzed in labs for gold concentration, measured in grams per ton. For open pit mines, anything above 1 gram per ton can be economically viable. High-grade underground deposits can run 8 to 10 grams per ton. The rarest bonanza-grade ore exceeds 20 grams per ton. Here's the brutal math. At an average open pit grade of 1.5 grams per ton, you need to move and process 20 tons of rock to produce a single ounce of gold. Now comes the moment that looks like war. A single blasting event in a large open pit mine can fracture and move 300,000 to 500,000 tons of rock in one detonation sequence. 5 to 10 rows of drill holes, loaded with explosives, detonated in precisely timed millisecond intervals designed so each blast wave compresses the rock in front of it, maximizing fracture, minimizing oversized boulders. The ground shakes like an earthquake, and the gold inside, invisible, microscopic, locked inside crystal lattices, hasn't moved a millimeter yet. After the blast, the machines move in. Hydraulic excavators, some of the largest land-based machines on Earth, scoop fractured ore into haul trucks with payloads of 200 to 300 tons per load. These trucks cost over $5 million each. Their tires alone cost $40,000. They run 24 hours a day, 365 days a year, grinding up ramps cut into the pit walls roads that spiral downward, sometimes 600 meters below the surface. Australia's Super Pit, one of the world's most famous open-cut gold mines, is 3.5 kilometers long, 1.6 kilometers wide, and over 675 meters deep. It's large enough to be seen from space. The ore goes to one place, the processing plant. But here's what surprises most people about gold mining. The real complexity isn't the blasting. It's what happens after the rock arrives. Because the gold you're trying to extract in most modern mines is completely invisible to the naked eye. It's not nuggets. It's not veins you can see glinting in the rock. It's microscopic particles locked inside sulfide minerals, distributed through millions of tons of unremarkable gray rock. To get it out, you have to destroy everything else. The first step is crushing. Primary crushers reduce meter-sized boulders to fist-sized chunks. Secondary crushers reduce those to gravel. Then the ore enters ball mills, rotating cylindrical drums, sometimes 12 meters in diameter, filled with steel balls weighing tons each. As the drum rotates, the steel balls cascade and grind the ore down to an extraordinarily fine powder. The target? Particles less than 70 micrometers in size, about the consistency of fine beach sand. At that scale, the gold particles previously locked inside the rock matrix are finally liberated, exposed, accessible. Water is added throughout, creating a dense slurry that moves through the plant by gravity and pump. From this point forward, everything is liquid. Now comes the part that most people find genuinely unsettling. To pull microscopic gold out of millions of tons of powdered rock, you add one of the most toxic chemicals known to industrial science: sodium cyanide. a solution so dangerous it's lethal in tiny concentrations. Yet it holds the key to modern gold extraction, and it's been used in mines worldwide for over 130 years. Here's why, and more importantly, here's exactly how it works. The powdered ore slurry flows into a series of large leach tanks, typically 6 or more in sequence. A dilute sodium cyanide solution is added, along with lime to control pH and oxygen to accelerate the reaction. Over 24 to 48 hours of continuous agitation, the cyanide forms a chemical bond specifically with gold and silver, dissolving them out of the solid rock particles and into the liquid solution. The rock stays behind, the gold moves into the water. This liquid is now called the pregnant solution, carrying dissolved gold in concentrations measured in parts per million. Next, activated carbon granules that look like coarse black sand are added to the tanks. The carbon has an extraordinary affinity for gold cyanide complexes. Within minutes, the dissolved gold adsorbs onto the carbon surface, stripping it from the liquid. The loaded carbon is then separated from the slurry and moved to the elution circuit, where a hot caustic solution strips the gold back off the carbon, concentrating it further into a rich, gold-bearing liquid. What happens next looks almost like magic. The gold-bearing liquid flows into electrowinning cells. An electrical current passes through the solution, and the gold dissolved, invisible, dissolved in liquid begins to plate out of solution as solid metal, depositing onto steel wool cathodes, turning a liquid back into a physical substance. The cathodes are removed, scraped, and what comes off is a dark, wet sludge. That sludge is mostly gold. The gold sludge is loaded into a smelting furnace heated to temperatures above 1064 degrees Celsius, the melting point of gold. Flux is a mixture of chemicals that causes impurities like silica, iron, and sulfides to separate and float to the surface as slag. The slag is poured off. What remains is liquid precious metal. This is poured into molds and cooled. The result is a doré bar, an alloy of gold and silver, typically containing 60 to 90% gold and weighing around 20 kilograms per bar, still not pure, but now a tradable, transportable form of precious metal worth hundreds of thousands of dollars each. Every doré bar is stamped, weighed, and logged traceable from the mine pit it came from to the vault it will eventually reach. But even this isn't the end. The doré bar still doesn't meet the standard required to trade on global markets. The London Bullion Market Association, the authority that sets the global benchmark for gold quality, demands a minimum purity of 99.5%. Premium investment-grade gold requires 99.99%. The doré must go to a certified refinery, and what happens there is the most precise transformation in all of metals processing. At the refinery, doré bars undergo either the Miller chlorination process, where chlorine gas is bubbled through molten gold, reacting with impurities and driving them to the surface as chloride slag, or electrolytic refining, where gold is dissolved in an acid bath and redeposited in pure form through electrical current. Either method produces gold at 99.99% purity 4 nines in the industry shorthand. The refined gold is cast into the standardized bars that trade on global markets, each one stamped with weight, purity, serial number, and refinery mark, each one meeting the London Bullion Market's good delivery standard. In 2025, gold closed the year up over 62%, with prices touching a record high of more than $3,500 per troy ounce. Central banks worldwide more than doubled their normal gold acquisition levels, buying physical bars at a pace not seen in decades. Every one of those bars started as invisible particles in 20 tons of blasted gray rock, from the first drill hole to the last cast bar, producing 1 kilogram of investment-grade gold takes. Months of geological exploration, millions of tons of blasted rock, precision chemistry running 24 hours a day, electrical current, fire, and at every stage, the extraordinary engineering of humans who figured out how to find something invisible, in concentrations measured in parts per million, was buried hundreds of meters underground, 3,300 metric tons of that every single year. The world runs on many things. Gold quietly, invisibly is one of them. Thanks for watching.